folks, it's me, Miss Rogers, and we're going to start talking about some more probability. Today we're going to talk about theoretical probability. Theoretical probability is the probability, a probability is a measure of chance that a specific event will occur. When all outcomes are equally likely, the theoretical probability that an event E is the ratio of the number of events favorable to the total number of outcomes. P just means probability. E means event. Probability has the values between 0 and 1. So it can be a fraction, decimal, or percent. So let's look at these examples. A spinner below is spun one time, and find the probability as a fraction, decimal, and percent. So a multiple of 3, number 8, letter A. The probability of a multiple of 3 happening. So let's count the multiples of 3. 3, 6, 9, 12, 15. How many dots did I put? Oops, you can't see. Now, how many dots did I put? 1, 2, 4, 5. Those are my favorable outcomes. So I have 5 outcomes. How many total? 1 through 16. 16 favorable. So that's what I get for that. So my total, I need to put into a decimal. Put in my handy dandy calculator, and I get 0.3125. And I changed it to a percent, sorry about that, to a percent by multiplying by 100. That would be 31.25%. All right, let's go with letter B, a prime number. Prime means, go here to the side, prime means divisible by 1 and itself. So let's talk about these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we've got those numbers on our spinner. Which numbers are prime? 1, by definition, is not prime. Because 1 divided by 1 is 1. It's not divisible by, it is, but it's not. By definition, it's not prime. 2, however, is divided by 1 and 2. It is prime. 3, divisible by 1 and 3. It is prime. 4 is not prime. You can divide it by 2. 5 is prime, only divisible by 1 and 5. 6, not prime, divisible by 2 or 3. 7, prime, only divisible by 1 and 7. 8, excuse me, not prime, divisible by 2 and 4. What about 9? It looks like it's following the pattern, but it's also divisible by 3. So it's not prime. 10 is divisible by 2 and 5. 11 is prime. 12, not prime. 13, prime. 14, not prime. 15, not prime. 16, not prime. So now we have how many favorable outcomes? Let's count them. 1, 2, 3, 4, 5, 6. 6 out of a total of 16. If I reduce that, that would be 3 out of 8. And if I do a handy dandy calculator trick, divide 3 by 8, I get 0.375. Multiply that by 100, I get 37.5%. Okay, let's try number C, letter C. An even number or an odd number. So let's mark our even numbers. I'm gonna put a little tick mark. 1, or 2, 4, 6, 8, 10, 12, 14, 16. I think I misread it. It said even or greater than 5. The word or means we're going to add. We're going to intersect our set. So we have 2, 4, 6, 8, 10, 12, 14, 16. So we have all those and the numbers greater than 5. So 5 is right here. We're going to go greater than 5. 6 is greater than 5, but it's already in our set. So 7. 8's in our set. Skip it. 9. 10 is in our set, so skip it. 11. 12's in our set, so skip it. And then add 13. 14's in our set, skip it, add 15. And we stop at 16 because it's in our set. How many have we added? Look at all the little purple marks. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. We have 13 possible out of a total of 16. And that is reduced. So we go to our next thing, our decimal, put it in the calculator. 0.8125. And change that to a percent, multiply by 100, 81.25%. Okay, so let's try one more. P of odd and at most 9. I'm going to go on the inside circle this time. All the odds, but at most 9. So we have at most, we're going to subtract. We're going to take away. And means subtract, or means plus. So the ones that at most, the highest we can go is 9. So I'm going to start counting. 1 is an odd. 2 is not. 3 is, and it's less than 9. 4 is even. 5 is not. 7, 5. There's 5. 6, 7, 8. I'm going to stop at 9 because it says at most. Right, so I have cannot go any higher than 9. 9 is my stopping point. So I'm going to go this way. 1, 2, 3, 4, 5. I have 5 out of 16. Put it in my calculator, and I get 0.3125. Then my multiply by 100, 31.25%. Okay. So let's look at number 2. A pencil box contains 5 red, 12 blue, 10 green, and 3 yellow markers. If a marker is chosen at random, what is the probability that it is not yellow? Not yellow. So let's think about that. Okay. So not yellow. We first need to know how many total markers we have. I have 5 red, 12 blue, 10 green, and 3 yellow. Add those up, 7, 10, carry the 1, 30. I have 30 markers. That's my total. So whatever I get, 30 is going to be on bottom. And I want to choose a marker that is not yellow. How many are not yellow? Let's see, 3 are yellow, so 30 minus 3 is 27. So how do I get that reduced? I put it in my calculator and I get 9 out of 10. There's my fraction. Number 3, what is the probability of drawing an ace or a diamond from a standard deck of playing cards? Well, how many aces are there? There are 4 aces. How many diamonds are there? There are 13 diamonds. But one of those 13 is an ace. So you take that and make it a 12. Because one of them is an ace. Okay? How many total are in the deck? 52. So out of these, I have 16 over 52. And that will reduce to 4 over 13. All right, this next one, number 4. It uses a tree diagram. So number 4, Finn guessed on the last 3 true-false questions. So let's draw a tree. So here's the Finn. He did the last 3 true-false questions. I do 1, 2, 3. Yeah, true, false, true, false, true, false. What's the probability he got exactly 2 questions correct? So true, false, true, false, true, false. Let's see. Nope, I did that wrong. Scratch that. Here's Finn. He either got one of them correct or incorrect. This is problem number 1. Problem number 2, he either got correct or incorrect. And if he got number 1 incorrect, he either got problem number 2 correct or incorrect. This is problem number 2. Problem number 3, if he got number 1 to 2 correct, then he either got number 3 correct or incorrect. Same with this one, correct or incorrect. This one, correct or incorrect. And this one, correct or incorrect. So here are the possible choices. Correct, 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 incorrect, correct, correct, incorrect. We only want the ones with 2 correct. So let's do that. Let me scratch this. So correct, correct, incorrect. Correct, incorrect, correct. Incorrect, correct, correct. Only 3 options. So let's write those down. So there are 3 out of 1, 2, 3, 4, 5, 6, 7, 8. Out of 8 possible. 1, 2, 3, 4, 5, 6, 7, 8. All right? That's a hard one. And we're not going to do number 5. All right, on the back. Venn diagram. How do we read this? Well, very carefully. Students in homeroom ask if they have a part-time job, blah, 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 blah. You can read that. So let's look at the Venn diagram. If you look at the whole circle, all of the numbers in the black circle had part-time jobs. So part-time jobs equals 14. We do the pink circle. Driver's license, we had 13. Look in the purple right here, where I'm shading, part-time and driver's license equals 6. So how many altogether? And then none, neither, equals 4. So how many altogether? See, we can't count this 6 twice. So how are we going to count this? So only if we only did part-time job, that would be the 8. If we only did driver's license, that would be 7. Then if we did the driver's license and the part-time job, that would be 6. Then we add in the 4. Then we can get our total students. 8 plus 7 is 15, plus 10, that's 25 total students. Okay, little crazy there for a minute. So let's look at this. The probability of having a part-time job. How many students had a part-time job? Well, we looked, it said not only part-time job, but total. So the part-time job, that was 14 out of 25. No driver's license, that would be total. No driver's license. How many did not have a driver's license? That would be 8. 12 out of 25. 8 plus 4 is 12. Part-time job and a driver's license. That would be the purple here. That would be 6 out of 25. Part-time job or a driver's license. That would be all 3 of these added together. That would be 21 out of 25. Driver's license and no part-time job. That would be 7 over 25. You're looking at just the part of pink. And we're not going to do number 7. Okay. And yeah, complement. This is easy. Complement just means we're going to do the not. This little tilde, the little squiggly means not. This complement just means not. And the sum of all complements in the sample space is 1. So we're going to do 1 minus the probability of an event. And this is easy to figure out. So like number 8. Probability that it will rain tomorrow is 11 out of 15. What's the probability that it will not rain? So 1 minus P of E, 1 minus 11 over 15 equals 4 out of 15. Probability, a number from 1 to 30 is selected at random. What is the probability of not selecting a multiple of 4? So divide 30 by 4 and take the whole number. That would be 7. Not the fraction, just the whole number. So there are 7 possible out of 30. We're going to subtract that from 1 because they want the ones that are not selected. That will give you 23 out of 30. All right. Experimental versus theoretical. Experimental means we're actually going to try and do the experiment. Theoretical means, hey, this is what it should be. So like probability of an orange. Getting orange is 1 out of 1, 2, 3, 4, 5. 5. Red or green is 2 out of 5. And not purple is 4 out of 5. Take the ones that are not purple and put it over 5. But experimental means we take the 50 results and the number of trials over the number of times. So the number of oranges, 12 over 50. And average is just a 6 over 25. It's a little bit different than 1 over 5. What about red or green? So we had red, 5 plus 10 is 15, or over 50, equals 3 over 10. 4 over 5, not purple, is 7. Well, 7 over 50. 1 minus, which is 43 over 50. All right. And that's all we're going to cover today. You should be able to do the homework, at least the first page. I want you to do 1 through 13, and then 15. 1 through 13, and then 15. I want you to do 1 through 12 even. Do number 13 and 15. So on your homework, 1 through 12 even, 13 and 15. That's the next worksheet. This is, I'm not even gonna lie, I don't remember what number it is. So there you go. Have a good day.